Alright, so given that we have our inverse, which is g of x is equal to 4, what we're saying is that this 4 is equal to our y value. So let's just write back our g of x is equal to x minus 2 over 3, right? And what we're saying is that our y value is equal to 4, so we're saying 4 is equal to x minus 2 over 3. And so we want to find what x is, and so we're basically doing the reverse. And so because we have the 3 in the denominator, we're going to time this by 4. By 3. To remove this denominator, we're going to multiply it on both sides. So we'll have 4 times 3 is equal to x minus 2. So this 3 will be cancelled, and it will be 4 times 3 is equal to x minus 2. And 4 times 3 will be equal to 12, equal to x minus 2. Because we have a minus 2 on this side, we're going to add 2 on both sides. So it will be 12 plus 2 is equal to x. Therefore, our x is equal to 14. And so that is our value for x. G inverse x is equal to 4. Now x is equal to 14. The y value was equal to 4. Alright. In which it says the diagram below shows a rectangular tank with a base 50 centimeter by 40 centimeter that is used to store water. The tank is filled with water to a depth of 15 centimeter. Calculate the volume of the tank, of the water in the tank, right? And so we know this tank is in the form of a cuboid, right? And so the volume for a cuboid is we got the base. All right, so I was thinking, as they give us a base, they give us the depth. I was going to say length times width times height, right? And so with that said, now our length would be equal to the 50 cm. Our width is equal to the 40 cm, and our height is equal to 15 cm. Right? With that said, we're going to times the 5 times 50 times 40 times 15, and our answer for our volume should be equal to 30,000 centimeter cube. And that would be the volume of the water in the tank. Alright, so this part question now, it has another question here in which we're going to find the cylindrical container shows in the diagram is used to fetch more water to the rectangular tank. On the other side, the container, which is completely filled with water, has a radius of 20 centimeter and a height of 21 centimeter. All the water in this container is added to the water in the rectangular container. Calculate the total volume of water that is now in the rectangular container. Alright, so we need to find the volume of this cylinder, or the cylindrical cube. To find the volume of a cylindrical cube, its volume is equal to pi r squared times height. And with that said, now we can use our pi. Alright, let's use our pi as 22 over 7. Our radius is equal to 20 squared, and our height is equal to 21. Right? We can do some cancelling because we see that we can say 77 1, 70 21 goes 3. And so we'd have 22 times 20 squared times 3. And that would give us a 26,400 centimeter cube. Alright, so with this volume, which is in the this container that we're using to fill the cuboid tank, what we're going to do now, we're going to add those two volumes to find the total volume. So the total volume, so the volume that we had of the water was 30,000. We're going to add this now to 26,400. And what that will give us is 56,400 centimeter cube, right? So the water that was already in the tank, which was the 30,000, plus this one which is in this container. We're going to add those two and we get 56,400. Alright, so part C now says, show the new depth of water in the rectangular tank is 28.2. So we know that the volume is 56,400, right? And to find the volume of that, we know we would have length times the width times height, right? And so what they ask us to find a new depth, right? So they want us to find a new height. We know we have 56,400, and the length still going to be 40 times 50. So the depth of the water is what we want to find. And so we can say 4 times 5, 20, so 5, 6, 400 equal to 2,000 times the height. We need to make I the subject to find it, so we're going to divide through by 2,000. And so what this will give us is a 28.2 centimeter is equal to height. And therefore, we were able to prove that the height is equal to a 28.2 centimeter. All right, so if we divide the 56,400 by 2,000, we should get 28.2. All right, so this part D now, it says the vertical height of the rectangular tank is 48 centimeter. We're going to determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. What we're going to do now, we're going to let the difference of the height equal to x. And so our x will be equal to 48 centimeter subtracted our height, which is 28.2 centimeter, and that difference would be equal to 19.8 centimeter. Right? Alright, so with that said now, we know that the volume of the cylinder that gives an increase of 13.2 centimeter. So we're going to time now the 2,6,400 over the volume equals the 13.2 times the 19.8. And when we do the cross product, we know that our volume will be equal to 522,720 divided by 13.2. This is equal to a 39.600 centimeter cube. Right? So what we did to find this, right? The volume that gave us the 26,400. We know that it increased by 13.2 centimeter, right? And so the number of cylinder equal 39,600 divided by 26,400, and that would be equal to 1.5. So we would need 1.5 more cylindrical containers to be poured into the tank to bring it up to a vertical height of 48 centimeters. Yeah. All right, so now in our question number 5, and it says, given the function f of x, which is equal to 3 plus 5x minus x squared, we're going to complete the table for this value. And what we have, when we see, we substituted our x as being, and this is the range that we're using from -1 to 6. These are the values of x. We're going to find what the function will be equal. We substituted our -1 in the function. We say 3 plus 5 times -1 would be -5, and -1 squared would be equal to a +1. That would be a +1. Still be a -1. So -5 and negative that, it would be equal to a -3. When we substituted our x as being 0, so what we're doing, we're saying 3 plus 5 minus square, right? We're going to substitute our x as being 0. 5 times 0, 0. X squared times that 0. So x will be equal to a 3. Alright? When we substitute our x as being 1 now, we can say now 3 plus 5 times 1, which is 5, minus 1 square, which is still 1. And so our answer will be 5 minus 1 will give us a 4. 4 plus 3 will give us a 7. Well, we're getting this value when our x is 3. We're going to say 5 times 3, 15. And 3 square, which is 9. 15 minus 9, 9, 10, which is 6. 6 plus 3, 6, 7, 8, 9. That's also equal to 9. Alright, when our x is equal to 4, we're going to say 5 times 4 is 20. 4, 4 is 16. 20 minus 16 equals 4. 4 plus 5 equals 7. And when our x is 6, 5 times 6 is 30. 6 squares is 36. 30 minus 36, that's equal a negative 6. A negative 6 plus a 3, that's a negative 3. Alright, so when we plug in these values, what we need to do is looking on our chart, we see our value for our on the y value, you see 1 unit as 2 square, but on our x, both on our x and our y, we see 1 unit value in 2 square, right? What we're going to do, when our x was a negative 1, our y was equal to a negative 3. Alright, so we know it's a 0. We know that this would be somewhere down this point. Let's use this x as right. When our x is 0, our y is equal to 3. This will be the next point. When our x is 1, our y is equal to 7. And when our x was 2, we see that our y is 9. When our x is 3, we see that our y is 9. When our x is 4, we see that our y is 7. And when our x is 5, we see that our y is 3. And when our x is 6, we see that our y is equal to a negative 3. And so what we're going to do, we're going to connect these lines. And this should give us a curve. Alright. So, apart from this little bend right there. Let me see. Ooh. No, x is 0. Yeah, that's why we didn't have that smooth curve. When our x was 0, y was equal to 3. So this curve right here, that's why our curve isn't as smooth as it should be. When our x is 0, our y was equal to 3. And we see our smooth curve right there. And that would be where we can plot the points from a range of -1 to x being 6. As you can see, the outer line would be our smooth curve. Alright, so we're asked to write down the equation of the axis of the symmetry of the graph 3 plus 4 plus 5x minus x squared. And then we could look on the graph and determine that value. But what we're going to use the equation of the axis of symmetry. And we're saying x is equal to minus 2
Go.
Alright, so it seems as if we got a little bit dumbfounded a while ago. So the axis of symmetry formula, which we're saying x is equal to minus b over 2a. Alright, from this function right here, if we were to rewrite it, it would be x squared minus x squared plus 5x plus 3, right? And so then it would be then f of x is equal to minus x squared plus 5x plus 3. We know in this,